Welcome to this ATA Insights webinar. Thank you for your ongoing interest and support of our webinar program. Today's session will begin in 2 minutes. ATA Insights Webinars is an online platform for the dissemination of professional renewable energy knowledge across international borders. Our aim is to democratize access to information, for innovation to spread faster, and to make the industry more competitive. And we do this through our online sessions, open to all our members. Every year, we do more than 100 sessions with over 250 speakers, 50,000 attendees from more than 50 countries. To participate in the session today, use the chat on the right-hand side to introduce yourself, your company, and where you're joining from. Under the screen, you will find the Q&A box, where you can send your questions for the speakers. We will get to as many as we can today. We're recording this session, and we will send you a link to the materials in a few days. Please consider supporting our content creation for the webinar program. Contact us on the email on screen. Well, good morning, good afternoon to everyone that is today here in the audience. Thank you very much for coming, whether you're joining us via Zoom or via YouTube. We really appreciate you being here. Today, we're going to be talking about energy storage, enabling large-scale dispatchable renewable energy on South Africa's grid. And South Africa must be one of the markets that I follow the most. I find it really, really interesting, everything that is happening there. And lately, with all of the movement towards storage, both the standalone and the hybrid projects that are appearing, I'm really looking forward to this specific session. I'd like to welcome, first of all, the speakers that we have today with us that are going to talk to us about this topic. Wallace, please, if you could very shortly introduce yourself so that people in the audience can get to know.
Good day, everyone. Thank you for joining. My name is Wallace Manyara, Business Development Manager for Watsila, based in Johannesburg, looking at countries like Angola, Botswana, and South Africa, looking at smaller market, which is off-grid, looking at mining companies. Looking forward to this interesting topic on large-scale renewables. Thank you.
Thank you very much, Wallace. I'd also like to ask Robert to please introduce yourself.
Good morning, everyone. Hi, this is Robert Futter from Cresco Project Finance, the director. We are very active in the renewable space, helping a lot of buyers as well as sellers in selling power or buying power, both in Africa and in South Africa, although South Africa obviously is booming at the moment with all the requirements and regulations hopefully freeing up, as well as the cost of Eskom making battery storage a bit more interesting. Maybe not just yet, but definitely getting there. Thank you.
Thank you very much, Robert. And I'd like to also ask Gabrielle, please, to introduce yourself.
Yes, thanks, Belen. Good morning, everyone. My name is Gabrielle Buccini. I work at Watsila in the energy storage business line, and I'm in charge of business development for Africa and Europe. So very glad to be here and excited to talk about South Africa. Definitely the very interesting market there.
Indeed, and it's very, very interesting marketing, a lot happening lately. So I'd like to I'm going to ask Wallace to prepare his presentation, actually for you to prepare your presentation, since you guys are going to be presenting and have already worked out, how to present together. So Wallace, you can share your screen, and whilst Wallace shares his screen, I'd like to give you a few housekeeping, just instructions, if you like. Please use the chat. Please introduce yourself and welcome Jason, welcome Kim. Yes, we can, and we can see it perfectly. So if you want to get started.
Not a problem. Sorry, guys, for the delay, bit of a technical glitch. Teams moving to Zoom, so trying to work that out. So briefly, we'll just go through the agenda. We have Cresco talking about the battery technologies in South Africa, and also looking at the Eskom tariff path, how they're looking at it from a financial modeling perspective and the mega flex structure. From then, we'll come back from a Watsila perspective to talk about how we perceive the South African market from a storage perspective, where we're going, and also looking at the GEMS digital energy storage platform, and then sort of look at where we've been as Watsila from a project perspective, what we've done, what we can look at doing further in South Africa going forward. And then we'll finish off with a number of dealing with the questions and answers that will come up during this presentation. So this slide talks to Watsila's experience, where we've been, where we've gone, and Watsila has got over 1.5 gigawatts experience of grid-scale energy storage experience. And looking at the map of the world, we've got some projects covering from the Americas, looking at California, looking at different modes of implementation of energy storage. Then we'll also look at the Africa-Europe group, where we've got a solid number of megawatts. And you sort of look at Mali, where this is an African project, we're looking at 17.3 megawatts of storage that we're looking at. And on the extreme right-hand side, we look at Singapore. This sort of shows the work Watsila has, and most surely if you do ask a question, why there's so much on the Americas side, the storage business with Watsila started with a business called Greensmith, and this has evolved to become part of Watsila. So you will see more of the implemented projects in that space going forward and looking at what we're doing as a business. At this stage, I will hand over to Robert to talk more of what they're doing in their business and seeing where they think the market is going, where they see the market is going. Over to you, Robert.
Cool. Thank you, Wallace, and good morning, everyone, again. So Cresco is a project finance advisory business. We've often supported IPPs into the government procurement programs and private sector procurement programs. But at the moment, most of my time is actually helping the buyers of power consider this interesting space called renewable energy procurement. What we have seen is that typically, and I'm going to just talk large mines, but let's call it large users, but most of our clients are actually mines, or you can see the Sasol's of the world on the list there. And there they have historically looked at this as a technical procurement process, but more and more they're realizing that the technology, and I'm talking more generation than battery specifically, is really the simple bit to understand and the proven bit to understand, but it's more around the commercial structure. And how does the commercial structure work? And more importantly, does the commercial structure work and does it make sense financially? And will it make sense financially for 20 years or 10 years, depending on your life of mine or the requirements to amortize the asset over its longest period as possible? So the clients on the list, the ones we've managed to actually build and put in place to date are largely cogeneration projects and have been involved in wheeling for a lot of these cogeneration projects. Historically, the reason these are the projects that have worked is because there was no regulatory constraint. A lot of the cogenerators already had existing generating licenses and they could just amend the generating license. They also had existing balance sheets and therefore didn't need long-term PPAs or project finance. So we've managed to help clients wheel and put some power on the grid, but not to the scale that we're talking now. Probably one of our most advanced projects is the Anglo-American Platinum project on Mogalakwena. In final stages of procurement there. We're helping on the Sasol where it's a very different scale, 600 megawatts being wheeled. But each of the clients on the list here are actually doing it for slightly different requirements. A lot of the larger clients are still Megaflex customers. And yes, we know that generation only, PV or wind makes sense today. And theoretically, if you don't have something in the ground, you're already losing money. But the idea of integrating battery storage, I think, is still starting to raise its head. Most of the battery storage projects that have been successful are actually outside of South Africa. And I touched on that in some of the slides. But what we are seeing are that IPPs are starting to consider battery storage solutions for on-site and for wheeling, primarily from a financial point of view. I know the Watsila team will talk more about the technical benefits of battery. I'm focusing more on the sort of financial benefits as a splitting of the slides. But for each of these clients, when we get engaged with them and we start with this sort of energy strategy work, and that's around what can we achieve today, what can we achieve tomorrow, and obviously going forward, the new technologies, the hydrogen of the world. But for us, battery storage is very much maybe here today or maybe nearly here tomorrow, both in terms of its financial ability as well as its implementation ability. And I'm talking here scale. I'm talking where we maybe have 80 megawatts of generation on site, and we start talking at 20, 30 megawatts of battery storage to get financial benefits. I'm less talking here about the small grid stability support. But you can see from the clients on the list, each of them have different targets. De Beers has a lot more of an aggressive timeline, which has been publicly stated than perhaps some of the larger ferrochrome industry requirements, who is very much looking at it from a cost point of view. But at the end of the day, carbon reduction and improvement in this space is also driving a lot of the benefits in the agendas. Next slide, please. So I think what has really been good out of the medium-term risk mitigation, and let's leave all the noise outside of that, is that people now are valuing, call it dispatchable power, both from a battery and a thermal point of view. I think previously people always said, well, you can't beat renewables, but I think renewables is helpful, but it's not the same as competing with a dispatchable type technology. And I think medium-term risk mitigation has definitely shown the cost of large-scale battery technologies, and they're very competitive. And I've got the example of the LNG examples there that are also in the range. So people have now set a benchmark for what is the cost of this beneficial technology out there. What we do see is, and everyone's got a view on what Eskom will do over time. The question is, does it double in the next 7 years, or does it double in the next 10 years? Unfortunately, for large users or even medium users, the story is quite a poor one in terms of increasing energy costs from Eskom. I know Eskom is preparing itself for large-scale renewable and embedded generation, which will include battery technology. And I believe the battery technology will help from a grid stability point of view and lots of technical benefits over time, balancing in that. I know that's where the market is going. But from a pure generation point of view, it's a real no-brainer at the moment. PV and wind are creating huge potentially savings offsets, specifically with Eskom's large increases over the next 2-3 years. We understand the 8.6 billion RCA is going to add a couple of percentage points to the already projections that are out there. And more as Eskom price increases, we believe that the battery storage solution answer becomes more scalable and more manageable. I think what medium-term risk mitigation has also done, besides set the benchmark, is allowed giving comfort that the funding is in place from commercial banks in rands. Generally in all our projects, we see it's the usual suspects sitting in Sandton or the centre of town who are funding these projects, so they're able to fund in rands. But now that they've set the benchmark around, are they willing to fund this technology? I believe there's a lot more application outside of government and more into the private sector procurement space. I think what I'm going to talk about next, and next slide, please. Is really around, I guess, energy arbitrage, the opportunity to use battery storage from a pure price perspective. As I mentioned, what's a little touch on the energy side. Now, we have the time of use structure in South Africa, and we have Eskom's proposed time of use changes, which were not approved last year, and we understand are now currently back at NERSA asking for approval. And in our view, this definitely makes sense, and time of use in the morning to the evening, largely driven by some of our demand patterns. And we do know that the stick of peak tariffs of close to 4 Rand now definitely does drive correct consumer behavior, and that's allowing the Eskom grid stability over these periods. In a normal world where we have enough energy for everyone, let's take out load shedding for the moment in this analysis. So today, we believe that perhaps at 4 Rand, just for peak hours for 3 months, energy battery storage for such a small portion probably doesn't make sense. But as Eskom prices increase, as potentially we see more and more projects benefiting from the time of use offset approach, we believe that the storage will include and become more beneficial. Now, what I'd like to say is when we work for private sector procurement, the approach is quite different to renewable or REAP. So REAP is obviously the lowest tariff, and it doesn't matter really when you generate, and that's how the PPA is structured. But the projects that we're working with our clients is we want the IPP to be incentivized to generate as much as you can in the higher time of use period, so being peak and standard specifically. Because of the high energy cost, as well as potentially in most cases, these large users are specifically reducing their demand in these periods because of price. And I guess that is where we think the battery storage solution, either on site or at the load, because I don't think for a wheeled project, it really matters where the battery sits commercially. Technically, I think there will be benefits at the load side, but we believe if we start optimizing this and getting higher NPV of savings, so for that is, call it Eskom only forever, Eskom plus IPP renewables, and the difference is the savings. And if you start looking at a 15% penetration for large users, we're probably seeing a 5% energy savings over the whole bill in the first year. Now, that might not sound a lot, but 5% over 20 years is a big number. And if you start adding battery storage in over time, where you start offsetting more of this peak and perhaps getting higher generation, those savings can only significantly increase. So we've seen a number of IPPs talk about bidding these projects with battery storage. We haven't seen any formal bids, most of them being for information, but we'd expect it in the next couple of procurements that we're involved in, and for the clients that on the previous pages, we actually might see some IPPs offer some alternative bids. In the programs we're involved in, we haven't limited them to generation only. We've said that you can include battery storage, but the storage would come at a variable tariff process. But if the storage starts looking more interesting and we start looking about on-site along with the grid stability, I believe that tariffing approach can definitely change. Next slide, please. So as I mentioned, when we talk about these adjudicating of the private sector, it's not about the lowest tariff. It's actually about maximizing your generation total, maximizing the generation, the time of use periods, and then obviously then looking at your current load profile and demand. Now, what we know is that for many IPPs on a generation only scenario, there's very little that they can do to adjust their dispatchability profile. The sun shines when it does and the wind shines when it does. And yes, they can get a lot of certainty, but they cannot guarantee dispatchability on Tuesday, the 3rd of June at 2 o'clock in the morning. By including battery storage, however, we believe that their ability to accurately dispatch, which one would help with their commercial proposal, help with Eskom's requirement for detailed generation outputs as well as load reduction, starts making these discussions more interesting. Now, for a typical wheeling project, this is currently in 2020 terms, a kilowatt of hour coming out roughly equally over the days, call it that, or a typical PV and wind generation profile will save you 83 cents. You can see there's a huge higher number for peak energy, standard and off-peak. Now that's in 2020 terms, and we battery storage definitely wasn't viable there. With the 15% increase this year, potentially another 10 to 15 next year, and another 10 the following year, I think you'd find that, and with battery storage prices coming down, we'd find that this arbitrage and this situation will look very different. And as the peak periods move over time, we see that this financial opportunity increases all the time. And as we said, if you're an IPP and you're bidding into these programs, if you can maximize your peak offset through whatever technical benefits that you can offer, that is often what is winning the bids. And because those peak hours are worth potentially 8 to 10 times what the off-peak hours are doing. Thank you. Next slide, please. So I think what we looked at is solar and the change in the profile here. So this is just one of our worked examples, and a lot of our clients, we're running these scenarios around what will Megaflex look like over time. And this is just one of the ones where we've said we'll move peak in the morning, from the evening to the morning, 2 to 3. Unfortunately, solar doesn't have much generation in the evenings, although we have seen that different parts of the country actually have better irradiation in the late afternoons, although they might not have higher load factors over the year. So it's maybe not all about the Northern Cape for captive power. You might find other locations also showing more interest, which I think also would help with the grid stability issues, because we are aware that there's a lot of overcapacity or not enough grid connection opportunities there. So as I said, for our clients here, we look at the total Eskom bill, we look at the sort of total costs, we look at the savings, and we look at what do we pay for the IPP. And in all cases, we've said generation only is a no-brainer. The question though is how often can we bring battery storage in to take benefit of the year? What scale do we see it coming in at? And obviously the price points. And I think what we're hoping to see over the next 6 to 9 months is maybe a typical project where you might have 100 megawatts of generation, but we might have 20 megawatts of battery storage with maybe 2-3 hours of battery storage opportunity. And that is some of the bids we expect to start seeing over time. And yes, they might not be a perfect answer today, but they definitely can be a perfect answer over time with the change in the Megaflex tariffs. And that also doesn't mean that we need to procure the battery on day one. We might procure the generation only, and the battery might come in later. And it could be from the same IPP, it could be on an EPC basis, or it could be procured completely separately. Because for us, you can commercially procure, and I guess technically also manage, and I know what Zilla will touch on that with some of their fancy software, but the different technologies in different ways, depending on what their required applications are. I'm going to now pass on to Wallace, who's going to take our numbers and facts and put them into real technical talk. Thank you.
Thanks, Robert. Much appreciated. And I think it's the numbers is what everybody's talking about. Do they work? Are they going to work? When will they work? So I think energy storage has been going around the rest of the world. The question is, how do we make it work in South Africa? And you cannot do that without talking about Eskom. Eskom generates the majority of the power in South Africa through coal, nuclear, hydro, pump storage, and supported by IPPs that have been awarded projects in the previous rounds. So adding storage helps, especially adding storage to flexible power plants and solar will give our country an opportunity to actually make our renewables dispatchable. And having large renewables will help our grid going forward and help us meet the peak demand or the growth of the demand of the country. And if you look at the IRP talks about energy storage, and we go like, where do we put energy storage in the South African context? Grid scale storage is an option. And if we look at it from a Wärtsilä perspective, a very, very recent development is the Pivot Power project in the UK, which is the first grid storage project that's been done, going straight into the grid. And this project will provide flexible capacity and reliability to support increased renewable generation. So if we look at our IRP, we've got a lot of renewables. We implement them, we will require more battery storage. We look at energy arbitrage. We look at peak demand reduction. And those are some of the things that Robert has talked about, so I won't really go into it. We look at backup so we believe that there is a big role storage can play in the South African context and covering our grid, strengthening our grid, providing stability. And also a key part will be distributed generation. There has always been a question, well, I need PV. But what happens when there's no PV or where the wind is not blowing? And the recent changes in the South African regulatory space also helps that, well, you can now increase your demand, have a bigger power plant or generating power plant, and you now have storage. So different scenarios, we foresee different scenarios where energy storage will play a significant role, but it all is based on what purpose is it, what are you using it for, and does it make sense at the end of the day? And you sort of look at what are the key sectors in South Africa where energy storage will sort of take center stage. And you will start with Eskom, as Eskom has got the storage tenders ongoing. I think there's 5 of them. And this is something that has been done to look at how storage can play in the South African grid scale capacity, according to the IRP, to look at how we manage the regulatory aspects of having grid storage and working with it. So we're looking forward to what happens in the 5 projects. I think they're totaling about 800 megawatt hours. That's quite interesting. And also from a recent announcement, I think it was a round 5 announcement by the IPP office, where they talked about having battery storage in the next round with about 513, in excess of 530 megawatts of battery storage playing a significant role. IPPs, it's a sector that we have seen, and as Robert said, we're starting to see storage coming into the picture. And with the RMIPP, we saw something very different coming up with hybrid solutions that include storage and renewables. When you now have renewables and make them large, the storage helps the renewables to become dispatchable. The captive market, where myself and my team are looking at in South Africa, we believe that with a few projects that have sort of started to go through, I think there's the Bushwood project that's gone through, starting to see clients questioning where do we have storage, we start to see plus 2 MWh storage solutions coming in, mostly in the mining sector, in the industrial sector. Also had inquiries from people in the data center industry. So we believe that in that space, there is a need for storage to play a critical role, and this will sort of also reduce stress on the grid while Eskom is going through rebuilding its capacity. Key game changer will be the president's announcement about 2 weeks ago. I think everybody was lobbying for 50 megawatts of embedded generation. The president gave us 2 times that of 100 megawatts. So that sort of creates a different scenarios for companies going for embedded generation. When you have up to 100 megawatts where you can pretty much almost self-generate, and most of the clients are looking at the renewable solution. And with that, how do you now make yourself, your power supply dependable and secure it? And storage plays a critical role in that. So we'll see a lot of hybrid solutions coming into the captive market, and my colleague Gabrielle will talk more about what Zilla has done, and sort of looking at the grid side, also looking at utilities, looking at the IPP. So most probably to be lessons learned for South Africa, and also use them for our market to see how we optimize that. The blessing that we have, that South Africa is a country that's abundant renewables capabilities, and now we plug in storage and make sure that we have security of supply. Over to you, Gabrielle.
Yep, thanks, Wallace. Look, I mean, where to start? It's always difficult, to be honest, to start and to talk about storage, just because of what you and Robert just said. I mean, there is plenty of applications. There's plenty of use cases that storage can serve. So here, what I'm going to present in the next really few slides is, I mean, I'll start from the brain. I mean, you mentioned what could be done. I'll just talk about how that can be done. And so basically starting from the brain, I mean, everybody knows battery storage is based on batteries. That is obvious. And everybody knows what kind of benefits and complications are around batteries to some extent. Now, what you don't see, but what is utmost important for this project is the brain, is the energy management system, which is the software. It's a software platform that will determine how the batteries will behave and how the various assets should be dispatched in a most optimal way. Our system is called GEMS. Again, it's a software platform. On this platform, we do run software modules essentially, and they interconnect with the existing assets, and they run and they determine how to mix and optimize the dispatches of all these assets at the same time, essentially. All the times keeping in mind that, of course, we want to minimize or we want to optimize how the batteries themselves are used, because we all know they will degrade over time, and that has to be, thoroughly controlled. Now that is GEMS. Of course, that is fully secure. It's a secure platform. I mean, there's a lot to do with. We're doing a lot of development in terms of cybersecurity, for instance, and these kind of things, because these platforms and the site then can be accessed from everywhere in the world, basically. Of course, with access rights, and so that's why we pay a lot of attention to cybersecurity, and we got specific certification in that sense. It is scalable and it is flexible, which is also a major feature of these systems. Flexible meaning, I'll just give you one example. A few years back, in the US, we had certain rules of the game. That was with PJM, and these rules were to be, and PJM decided to change certain things, and hence the mission of the battery, the existing battery storage, would have to be different. Now, thanks to the fact that the brain is the software, and the software can be run and engineered remotely. So we did the changes, we did the simulations, and we then uploaded the new software with the new rules, according to the new rules in the system, with a very low disruption of the system itself. So the system could, almost didn't even know, or the operations were not even disrupted, but the system then from the next day was able to follow the new rules. And that is something major. That's not a detail. That's not something that other, or let's say standard historical systems can do very well. And yeah, and just the last thing about the how many of these we've done. I mean, GEMS is the key is on the 5th or 6th release now. It's been a kept-on project for like 10 years, on more than 85 now, and this number is growing quickly. And yeah, so I mean, our expertise is quite significant, I would say, if not more than that. And yeah, Wallace, maybe the next slide. This is still about GEMS, i.e. the brain of the system. This slide talks about intelligence. Well, that's what it is. It just connects all the equipment that you see on the bottom. It doesn't matter whether they are new equipment or existing one. It's only a matter of communication protocols to be adapted. But at the end of the day, the GEMS core will not change. The brain will not change. It also, GEMS can also receive inputs from SCADA, from weather forecast, or from energy market itself. Then it will combine all these information, run them according to whatever mission has been built on, and then deliver the solution, which can be from microgrids to grid stability, grid reliability, or renewable integration. I mean, those are the keywords that also Robert and Wallace mentioned a few times. Yeah, so maybe Wallace, next slide. It's about, yeah, some real stuff. So I just show you, I mean, it was just the boxes there. No, these are pictures, meaning existing sites. Starting from the left, well, I have another slide on this one on the left, which is a mine in Mali. So I'll just skip it maybe for now. So the one in the middle is a small island. It's about 5,000 people living in this island, this beautiful island, India's Oz. We've equipped this island with a battery storage system and GEMS, and we are interconnecting existing PV and wind and engines generation assets there, which were existing before. Now, the problem they had was that these systems, as we repeatedly said, they were intermittent, they were not, reliable from a weather forecast point of view. And hence, the engines have to be kind of on all the times, just in case the wind goes down or, some clouds pass by. And that was not efficient at all, I would say. After installing storage, and we're not talking about big numbers, by the way, you see it's only 6 megawatt, 3 megawatt hours. So it's really a small number, but just follow the concept. The concept is that they couldn't do it without storage. With storage, and that has been installed, I think, at least 2 years ago now, they were able to run 2020. They were able to run on more than 100 days without any engines on. So the island was completely powered on renewable basis. They managed to reach, I think, around 60% of the total energy produced and used in 2020 was coming from renewable assets. And these numbers were nowhere to be met without storage. There was really no way to reach these numbers. And yeah, so that's the tiny island, which is anyway, which one could compare to an electrical island like the Mali mine, which is off grid as well. And then going a bit bigger, and that's where the market is going, by the way. We're going more to bigger and bigger projects. So this is a project we delivered last year in California. It's, as you can see from the picture, tied to a wind farm, a large wind farm, which was already existing. Now, with this system, the owner of the two sites is able to combine the benefits of storage, meaning doing arbitrage, and meaning also getting contracts for ancillary services with CAISO, and also at the same time dispatch the wind in the most optimal way. And again, just to connect to something that was said before, there is a business case. I mean, battery storage works in certain business cases, like Robert said. It is a matter of cost, it is a matter of benefits and revenues. Well, one important aspect and storage can do that is that it can stack its value stacking. So basically, storage can do more than one thing at the same time. So one customer can get more than one revenue stream at the same time. And of course, the more revenue streams you can have, and that depends on the energy market you're working in, but the more of them you can have, the more easy, or the easier will be the business case for storage systems. So certain markets, like in the US, is there, and that's why we have so many projects. In other markets, this is just the beginning. I mean, we're just at the beginning of it. Now, moving on, the Mali case, it's the project. This project we've delivered it, I think, a few weeks back, commissioned it, sorry. It was just it was a mine. It is a mine. It's B2 Gold. It's a large gold mine in Mali, and they were running the mine with about 60 megawatt of engines installed, not Wärtsilä engines. They were someone else's engine. And well, because of decarbonization requirements, because of cost drivers, they decided to go for hybridization of these plants. So they decided to build a PV plant. And also this is just back to what Robert said about when this investment could be done. Well, there's no need to do this investment at the same time. In this case, the mine decided they already had the engines. They decided to invest in PV and at the same time hire the consultant to go and define what would be the best battery storage system in order to optimize the whole mix of assets they were about to have. And they decided to go for a 70 megawatt, 15 megawatt hour storage system, which we got awarded and we delivered and we commissioned a few weeks back. Now, the benefits are, I mean, it's a short payback. I've seen numbers now, I can't recall the number exactly, but it's really within a few years, the battery storage will be paying itself. And then it's about decarbonization. Of course, the CO2 emission will be much lowered. And then it's a cost as well. It's a cost driver as well. The whole energy generation cost is going to reduce. And then on the next and last slide from me, Wallace, so that we can have some time for Q&A. Yeah, so this is it. I mean, this is, as you can see, this is May 2020. It's a screenshot. What you see on the right-hand side, it's a screenshot of our user interface. It's not so, I mean, it's not only that, of course, you can click and see and drill down to the single equipment deployed at site and see what the system is doing. Even, I mean, through the battery cell status, like voltage and temperature, that also can be seen from remote location. And that is very useful for troubleshooting, clearly. But now this is, as you can see, it's 2020. I said that the system has been delivered a few weeks back. So this, what you're looking at here, it's in fact a screenshot of a simulation we were doing last year. And the simulation here is about, well, you see, it's a 24 hours period, I think. And you can see that there's a dark orange that on the upper part of, on the upper chart. The orange part is the energy delivered by the engines. And then you see at some point around 7 a.m., the PV is kicking in. So it goes up and then it takes almost 80% of the production at, around 1 p.m. And it goes down again with some fluctuations because probably of clouds that we were simulating on that particular day. And what happens is that thanks to storage, the engine, well, storage and I would say GEMS in particular will be able to dispatch and to do the tertiary control, what we call, so meaning dispatching on the long term the assets at site. And you can see that the engines, which are 1, 2, 3, 4, 5, 6 engines below, are kind of shut down one after the other as the PV increase. And then at some point you only have a few engines on, and then after that, GEMS will determine which engines should be switch on again when the evening comes. In this case, of course, GEMS and the battery storage size is only 1 hour, so it's not providing energy shifting. It's just providing spinning reserve. So meaning that you can switch off the engines without without the risk of incurring in shutdowns if there is a sudden drop of PV or something like that. Or maybe even if one engine existing or which is on would trip for any reason, then the batteries would kick in and just stabilize the frequency and the voltage for some time until you can switch on the next engine. So that's one of the many applications storage can have, and that is just the example of when we were doing Fecola simulation. But there is much more than that, of course. And yeah, time is up now. We can't close them. I mean, I can't go through them, but yeah, then it's up for Q&A, I would say. And back to you, Wallace or Belen.
Thank you very much, Gabriele. Thank you very much, Wallace. And thank you very much, Robert, for sharing all of this know-how with us. There is a lot of questions from people, especially a lot of questions about GEMS. So I suspect that you're going to be busy answering them, Gabriele. But I'd like to ask first a few questions of myself, if I may. The first ones are for Robert. It's just some clarification questions, and so that we're all clear. Robert, when we're procuring renewable energy, can a generation technology and a storage technology be procured from different people or at different times?
Thank you for the question and great presentations from the Zilla team. At the moment, specifically in South Africa, we believe that battery storage maybe just isn't there or soon will be there, as I mentioned earlier. But most of our clients are pushing ahead with aggressive renewable energy implementations, knowing that there's still a bit of a path to walk. The 100 megawatt exemption sounds great. We still don't know about the details, so there's still going to be some delays there. So people are now saying, if I go out at the moment, what should I be procuring? And as I mentioned, what we're trying to say to our clients is procure generation offset. And if the IPP would like to put battery storage in their technical solution, so be it. If they can't put it in today, but they believe they can put it in next year, then let's go back to them and make that offer. I mean, in many cases, the IPP who's providing the solution is buying the battery storage from an OEM type person. And therefore, the battery storage could be included on a very much open book basis with the same cost of funding that's attached to the generation, perhaps being attached to the storage solution. So we are trying to be flexible in our procurement. As I said, we're hoping to see firm bids in a few months' time from IPPs where they're willing to put the battery storage technology firmly in their grip and say, I'm willing to price this over a 6-month period, subject to exchange rates changing and things like that. And the way we do procure, we do allow the tariff to be adjusted for things that are outside of both the buyer's control and the seller's control. In Africa, we have a really good project in Madagascar where we actually have a 7 megawatt project. I know Wadzilla is also engaged in that one. It wasn't on their list, but there we have PV and wind and the battery there, and that's offsetting HFO. And there the answer is already there that it makes sense. This battery is actually being largely used for technical reasons because it's an island grid and there's no real time of use requirements per se. And it's there, and I think we're getting about a 55 to 60% penetration, similar to the Azores Island, if I understood from the example. So there we've seen it come in on day one as part of the solution, but there PV is coming on quicker than wind. So we have battery for PV, which is smaller, and then battery for the wind coming on later. So there they are being procured slightly behind each other, and the battery for the PV is firm today because we can price it. Whereas the battery for the wind, the cost of that is going to be transferred through a transparent commercial negotiation in that. I hope that answers the question. Thank you.
I think so. Thank you very much, Robert, for going into such detail. Here's one more question for you, and then we'll go into the more technical bits, if you like. Although this is very technical, but more market-like. When procuring renewable energy on a wheeled basis, so when, where I'm generating and what I'm consuming is not directly connected, does the storage technology have to be at the buyer? So on the side of the buyer, on the level of the generation, the IPP side, I mean, if procured from the same party?
Yeah, so I mean, I think what we've seen is that unfortunately, a lot of the big loads in South Africa, unfortunately, are not sitting in the best irradiation areas, or there are site limitations or community limitations or whatever. So a lot of them are looking at on-site generation, but are limited due to site availability. So the real large penetration of renewables is going to be through wheeling. And I think Eskom is setting themselves up for that, as I mentioned. For me, commercially, there's no reason, and I'm sure there's a technical reason, but commercially, there's no reason why the battery can't be either at the load or at the generator's site, depending on where the risk allocation needs to sit. More and more, I believe that, and as Gabrielle mentioned, there are more than just a revenue savings opportunity for batteries. There's lots of other potential revenue drivers, which could also include lost production from this. So I don't see why, if you had a battery storage solution for generation, you'll have the IPP offering generation in the Northern Cape or Western Cape if it's wind or whatever, and then the battery storage from the same provider could actually sit at the site. And because batteries take a lot less space, they can sit behind the grid connection. There might be some interface requirement, and I'm sure Wadzilla can touch on that. And that can be managed remotely, as we've seen from GEMS, and that will provide the client with a seamless, on the one hand, large-scale renewable, on the other side, some technical benefits, which for me makes that more of opportunity. I know in medium-term risk mitigation, ancillary services did come with a value attached to it. So if you can also consider that as part of your business case, then I believe batteries is probably earlier than what I mentioned earlier in my discussion. Thank you.
Thank you very much, Robert. There's a bunch of questions from the audience, but don't worry, we'll do this. We'll take as many as we can, and then when push comes to shove, we'll pass them on to the speakers so that they can answer them directly to you. So the question I want to ask you, Wallace and Gabriele, is about where the market is in South Africa is going in terms of flexibility. Where do you see the market going for flexibility solutions like energy storage? What projects are you looking at? And all within the context of, how do you see the optimal energy mix in South Africa, becoming in time? And what is the role of dispatchable solutions? So I just kind of mixed, I had two questions, but I mixed them on one. Like, where do you see the market going really? And what's the role? So who wants to take this first?
Can I go first?
Go.
Cool, thanks. So I think what defines our market in general is we start with the IRP. So the latest IRP defines what the energy mix is for South Africa, and there is space for storage, there's space for renewables. We see those coming. So from my perspective, more of delivering what has been in the IRP, and most probably an update will come soon. So a combination of renewables, which are PV and wind, and you see a lot of storage coming in. Another one will be the core repurposing. What comes into the repurposing? So you talked about flexibility. We see flexible power plants, powered gas engines. So also availability of gas in South Africa, when and how. So we believe that the RMIPP, which is now being adjudicated and most probably, I think, financial close quite soon, kind of like leads that avenue in terms of where the market is going. So we'll see more to that. And the RMIPP has sort of defined in a way that hybrids are coming to South Africa, will be here to stay, combination of PV, gas, and storage. So we'll see lots of that going on. So I think this is where I see the market going. It is an exciting time in South Africa, so we'll see lots of storage. I don't think that South Africa will miss it in any way.
Gabriele?
Yeah, no, I mean, I fully agree with you, Wallace. Of course, how could I disagree? But no, look, it's just, it's you're spot on. I would say, I mean, in my mind, the key word there is really, at least at this stage, is really dispatchability. And so we see that we've moved from but I mean, there's then obvious, I mean, I may say, difference between the whole idea of the renewable IPP program so far and the RM IPP program. So the notion of dispatchability is really the novelty in the RM IPP, and that's what's going to, I mean, that's what changing completely the game, the rule of the games there. And then, as you said, you already mentioned, I mean, Eskom, and then we'll see now with the captive market also probably coming up. But yeah, I would say dispatchability is really where the market is, what the market needs. And we've seen also from the small, tiny, and that's a small example, but we can extrapolate that kind of, phenomenon to a wider grid, to a bigger grid.
Thank you very much. So there's a bunch of questions about GEMS, and I want to ask you, because for me, without GEMS or without, the management system, there is, the battery by itself, they certainly can do certain things, but it doesn't really make that much sense. And it's very, very hard to find the business case without the brain to bring it together. So there's two questions that are related. One of them asks, why lithium? Why is it a popular choice? Why lithium? I suppose, although I'm going to ask you, that you're going to say because it's so flexible and it can do so many things, right? But I suppose the question here really is, GEMS. What is GEMS exactly? Are you like a battery management system? Is it like a energy dispatch management system? How does it sit in terms of the architecture of that specific solution? Considering, but like getting back to this thing of why lithium, I think it's very connected. So Gabriele, I don't know if it's a question, but I think I'll give you.
No, I mean, why lithium? Why lithium? Basically, I mean, it's just that. To be honest, I mean, I've ended up in this business when lithium batteries were already, had already the lion's share. So I can't really comment much about what happened in 10 years ago when different kind of chemistries were battling a lot. Now there is no doubt it's lithium-ion batteries. It's reliable. It's proven. The cost is going down. It's just, I mean, the more you develop, the more you deploy, the less it costs. and then it's just it just goes in that direction. So it's hard for other technologies to compete. I'm not saying in future that, there may be other technologies competing in future. That's very possible. I don't have a crystal ball, but so far, we don't see any. That's what the market offers. And yeah, it's then on lithium ion, there are of course several chemistries. So we're now, what we have deployed in the past several chemistries for the cathodes. And now I would say that in the past we were more on NMC batteries. Now it's more LFP batteries, but I don't, it could be that we go back to NMC batteries in future as well. Both have pros and cons. I don't think here we have time to debate too much about what they are, but it's both currently in the market, that's for sure. And now in terms of GEMS, that's also a big question, but it's not a battery management system. If you, on a simplistic level, you could see that the BMS, the battery management system, is a lower level. It's more a monitoring system to manage batteries and see temperatures and voltage, but it doesn't really tell the batteries what to do. It's more, okay, now this is not entirely correct, but you can see more as a sort of a monitor and safety system, if you like. Whereas GEMS is more acting, or any EMS in particular, is more acting on a higher level. So it will get inputs from the market, from the weather, from other assets, that it will, crunch this data. And then the output will be a dispatch instruction to the assets, to the batteries, and so on. So it's a simplistic, I know, but it's like in a battery storage system, one should look at the batteries like the muscles, and GEMS as the brain. And and a body without brain wouldn't work, and without muscles wouldn't work either. So there are, just to complete and be maybe a bit more precise, there are a few things there are a few applications that are not sophisticated and that can be done with a very simple EMS. But again, those kind of applications like responding on frequency deviation, that is doable without a sophisticated system. But again, that is just one single application. And as we said before, the more applications you can do at the same time, the better is the business case. So we definitely see the market going to sophisticated systems rather than simple reactive systems.
And perhaps I could just take one step above there. So we engaged a lot with Eskom for our clients, and we have clients who have potentially a number of generators, a number of loads, number of different technologies interfacing both at an on-site and a wheeled solution. And I know with this whole 100 megawatt exemption, theoretically, there's going to be a whole lot of renewable energy and everyone's going to be doing it where they are. And I think this whole relationship between the generator and the load, on-site or wheeling, plus the battery in the middle, plus Eskom in the middle, 24-hour, 48-hour reforecasting, bad weather coming in is becoming so much more important, both for Eskom as the system operator, for the generator, for companies in a group where maybe they have 1,000 megawatts of generation versus 1,000 megawatts of demand, but this demand and the generation is moving all over the place. So I believe this sort of software system, we're talking very project specific here, but there also needs to be one sitting at the top to manage the commercial and the total generation. And yes, Eskom will be part of the solution and the interface, but I think companies themselves maybe have to take that step up. Thank you.
Thank you very much, Robert. Yes, absolutely. Thank you very much for explaining that with the muscle and the brain, because I have understood it perfectly, and I'm sure I'm not the only one. It works in many, many levels. So understood that is more of the relation that your battery has with the rest of the world kind of thing. It's like, how does it operate in terms of that, and how does it get better at like making you money, which is, at the end of the day, what's important, how it's reacting to the market. That is excellent explanation. There is a couple of questions more here about whether it can deal with hybrid systems and it can like integrate with other I suppose BMAs and other systems. Gabriele, if you don't mind.
I haven't seen that question. Can we answer questions after we close this?
Sure. Yeah. By all means. Okay. Like I was just following up on that. Okay, so then we don't have much time at the moment since there is just 3 minutes. So just a couple of questions for you. What does the maintenance of storage technologies entail, and is it costly? This is one of them.
Wallace, do you want to take this one? Unmute. Yeah.
Yes, on mute. So I think if you compared it to the current technology, current plants that we're working with, the management of energy system, it is way more cost effective than what you're looking at running either gas engine, gas turbine technology. So we believe that it's a cost effective management system on O&M life, much better than the technologies that are out there. So definitely a cheaper option.
Would you like to add anything, Gabriele?
No, I mean, just because we don't have time.
Okay, it's literally 2 minutes now, so I'd just like to ask you one more question, which has been hinted at here, and is the case for green hydrogen. I know it's a little off topic, but I just, in terms of context and of management, I mean, Varsila has been like one of the leaders in motors, and engines. So this seems like a very good area for development and where you for sure are doing work. So I just like to see, if you could, whether you see like this is a good solution in the case of South Africa, or, that perhaps, we need to still wait until the costs come down. I don't know. What do you see as green hydrogen to be the potential in South Africa and in Southern Africa, really? Who wants to take this? Wallace, go for it.
I'm happy to ever go. I think it's been questions that have been asked quite a lot of times. So I think we're looking at what's going on in the world with green hydrogen and sort of the benefits, the costs, and I think most of the OEMs are looking at it. So from a Wärtsilä perspective, we're not just looking at green hydrogen, we're looking at other fuels, that can make that makes sense. So it's something that we're looking at and something that we'll see ourselves being competitive in that space. So it's something that's currently in R&D, I would say. So timelines very soon, I would say.
And perhaps I could just jump in here. So when you look at a lot of our clients, Eskom is one component, but diesel is also significant. So everyone's talking about it. There's only a few people actually doing things from what we can see. So we say to most of our clients as part of our energy strategy, keep your finger on the pulse, understand what's there, make sure you have a plan to be in place. But so there's always a right time to invest, but don't wait till the end, but be aware of what's going on. Because just like the renewable technology, there's a learning curve, but there's also a bit of first mover advantage to getting savings from day one.
Excellent. Thank you very much, Robert. Wallace, please, would you put your details for all attendees there in case anyone wants to reach out to you directly? And other than that, I'd just like to take this opportunity to say thank you to Wallace, to Robert, and to Gabriele for their intervention and their help and their expertise. You're going to have Wallace's details, and if you would like to be put in touch, there's not a problem. We have recorded the session and it will be sent to you. Thank you very much for everyone that is there in the audience. Main takeaways for me is that this is, it's undeniable that as you go to more renewables, you need more dispatchability. It is something that was completely taken for granted. It wasn't a thing, really, when you just had essentially synchronous oil and gas, coal in the system. But now as you go into more renewables, you have to think about this. You have to think about your resource, and you have to think about your demand and how to match resource and demand. And that is what makes it a little bit tricky on the side of the planners. But the technology, thankfully, is there for us, and it can be answered. And the markets become infinitely more interesting, as time goes on. As you can see, markets that are already developed in terms of storage, like the UK. So I'm really looking forward to see, all of these new solutions now being more and more deployed in South Africa and other markets. So thank you very much to the three of you, and thank you very much as well for everyone that is on the audience. And we will see you next time. Thank you.
Thanks, everyone. Thank you, Belinda.